Now we're going to take a quick look at the volume of pyramids and cones. So just so you know, one of the components of a cone is the axis, and that connects the center of the base to the apex. You can see it marked there. Right cones, the axis is straight up and down, perpendicular to the base. And in fact, it will be the same as the height in right cones. And here I've drawn a line that's parallel to the base so that you can see they make a right angle on this one. Here, this is not a right angle. So on right cones, the height and the axis will be the same thing. But oblique cones are when the axis is not perpendicular to the base, and you can see that the height is actually going to be shorter than the axis. Luckily, we're not going to run into a lot of problems where we're dealing with oblique cones and that potential right triangle. So that is the oblique cone. And let's go ahead and take a look at the volume. There's a very cool derivation where they basically showed that a right square pyramid is exactly 1/3 the volume of a cube with the same base. And that leads to our formula, that leads to our formula for pyramids and cones, which is volume is 1/3 the base times the height, where B is the area of the base. And that's the yellow part here. H is the height of the solid, and that's the blue part there. You might end up using trigonometry or Pythagorean theorem to find missing dimensions on here, especially if we give you the slant height and we want you to find the height or the radius. So here's an example where we want to find the volume of the right cone in terms of pi, which means I don't want a decimal answer. So I'm going to use the formula. Volume is 1/3 base times height. And I know I can see my height is 24. I don't know the area of the base, but I know it's a circle, so the formula for the base area is pi r squared. Well, I don't know what the radius is, which is this part here. So I can use Pythagorean theorem because you can see this right triangle that's formed. And I can say 24 squared plus r squared equals 25 squared. Squaring both numbers, I get 576 plus r squared equals 625. Subtract 576 from both sides, and I get r squared equals 49. So that means the radius is 7. Now I can find the area of the base, pi times 7 squared, or 49 pi. And I'm almost done. I have the height, I have the base, so now I can just substitute. Volume is 1/3 times 49 times pi times 25. And if I were to just multiply the numerator numbers, I get 1225 pi all over 3. And that is the exact answer in terms of pi. When we say in terms of pi, that means leave the pi there. Don't hit the pi button on your calculator. All right, now we're going to find the volume to the nearest square inch of a square pyramid with a slant height of 18 inches and a lateral area of 288 inches, and that should be cubed. No, lateral area is squared. I'm fine. So anyways, there's my slant height. It's 18 inches. And since I know this 288, I'm going to go ahead and use the whole formula. The lateral surface area is 1/2 perimeter times length. Remember, we learned that in our previous section. Now, the reason it's very important to write both sides of the formula is this 288, you don't know where to put it if you only use this right side of the formula. It actually goes right here. And the 18 will go on the L. So substituting in, I have 288 equals 1/2 perimeter times 18 inches. Now in this particular example, I went ahead and I left the units in so you can see what happens. Now I have 288 inches squared is 9 inches times the perimeter. I'm going to divide both sides by 9 inches. And by the way, the inches squared here becomes inches. Inches squared divided by inches is inches. Here, the inches simplify. So I end up with 32 inches as the perimeter. Since this is a square, that means the perimeter is just 4 times the side length. Well, I can figure out then that the side length is going to be 8. My square has sides 8, so the base area is side squared, which is 64. So continuing on with this problem, I know the base area is 64 inches squared, and I'm trying to find this volume, 1/3 base times height. So I have the base, I still need the height. right here. Now, if you look at it, there's another piece here. These three pieces form a right triangle. I actually know this piece because it's halfway across a square. It's going to be half of 8, which is 4. Well, I'm still trying to find the height, so I can actually use Pythagorean theorem because there's a right triangle here with 18, 4, and h. Substituting in 4 squared plus h squared equals 18 squared. Squaring both numbers and then subtracting from both sides, I get h squared equals 308. Take the square root. H is the square root of 308. So then I just substitute in the height. I already had the area. Get my calculator out, and if I round to the nearest whole inch, I get 374 inches cubed. So some things to reflect upon. When are the height and the axis of a cone the same? What prior concepts might you need to use to find missing values? We've been using Pythagorean theorem, we've been using trig. We will often use the area as 1/2 the apothem times the perimeter for regular polygons. So there's a lot of different things we can use that we've already learned this year. Why is it so important to write down the entire formula rather than just the right side of the formula? Remember, I can give you values that go on either of those sides. It doesn't just have to be on the right.